So hello everyone, myself Mankskla, and today in this video I'm gonna teach you about the Van't Hoff factor, which is one of the most important topic for the JEE as well as the NEET exam. So without wasting any time, let's move to the topic. So first of all, we will talk about what is the definition of Van't Hoff factor. So exactly what is the Van't Hoff factor we will teach in this video first of all. So definition पे आते हैं तो the extent to which a substance associates or dissociates in solution described by the Van't Hoff factor. तो अगर इस डेफिनेशन की हम थ्योरेटिकल लैंग्वेज से हटके कॉमन लैंग्वेज में बोलते हैं तो जब हम किसी सब्सटेंस को किसी सॉल्यूशन में डालते हैं तो या तो वो एसोसिएट होता है या डिसोसिएट होता है, तो वो कितना एसोसिएट हुआ है या कितना डिसोसिएट हुआ है, दिस इज व्हाट वी कॉल Van't Hoff factor, or this is what by which we calculate is Van't Hoff factor. So like जैसे कि हम किसी भी चीज़ को वाटर में डिसॉल्व करते हैं या किसी भी सॉल्वेंट में डिसॉल्व करते हैं, लाइक हम शुगर, जैसे कि हमारा ग्लूकोज है, ग्लूकोज को अगर हम वाटर में या किसी भी चीज़ में डिसॉल्व करेंगे तो ये एज इट इज रहेगा उसके अंदर। तो एक ही मोल अगर हमने इसका डाला है तो ये एक ही मोल में प्रेजेंट रहेगा। बट अगर हम बात करें किसी सॉल्ट की, लाइक NaCl, तो NaCl को अगर हम किसी सॉल्ट में डिसॉल्व करेंगे तो हमारा टूट जाएगा Na प्लस एंड Cl माइनस में। तो अगर हमने स्टार्टिंग में इसका डाला है 1 मोल तो 1 मोल Na प्लस बनाएगा एंड 1 मोल Cl माइनस बनाएगा। तो इस तरह से इसके बन जाएंगे टोटल 2 मोल। तो हमने डाला था 1 लेकिन बन गए हैं 2। तो इस तरह से किसी भी सॉल्यूशन के अंदर जब हम किसी सॉल्यूट या किसी भी सॉल्वेंट के अंदर जब किसी सॉल्यूट को मिलाते हैं तो उसके नंबर ऑफ मोल्स या फिर नंबर ऑफ उसकी प्रॉपर्टीज जो होती है उनको हम चेक करते हैं बाय द Van't Hoff फैक्टर। सो अब बात करते हैं हम इसके फॉर्मूले की। So formula of this is I is equal to observed colligative properties upon the theoretical colligative properties. So colligative properties क्या होती है ये हम अलग वीडियो में बात करेंगे, लेकिन अगर हम यहाँ पे बात करें जैसा कि हमने अभी समझाया था कि लाइक नंबर ऑफ मोल्स हमारे डालने से पहले जो थे और जो सॉल्यूशन के अंदर नंबर ऑफ मोल्स है उनमें आ चुका है चेंजेस, तो एक तरीके से हम उसको एज अ colligative प्रॉपर्टीज काउंट करके हम आगे बढ़ सकते हैं। सो I is equal to for any compound I is equal to n that is observed upon the n that is theoretical will be the difference, and this will be the value of I. So if we move further and solve this formula, then n we can write this n as the weight upon the molecular observed weight upon the weight upon the molecular theoretical weight. This can be our formula for further. So now the weight that we have put in this solution will be the same. हमने जो वेट सॉल्यूशन में डाला है वो सेम रहेगा क्योंकि उसकी क्वांटिटी में कोई भी डिफरेंस नहीं आएगा, लेकिन हमारा जो मॉलिक्यूलर वेट है उसकी क्वांटिटी में चेंज आ सकता है, क्योंकि जैसा कि हमने अभी देखा था कि Na प्लस और Cl माइनस में हमारा जो NaCl है वो टूट जाता है। तो इससे क्या होगा कि NaCl का जो मॉलिक्यूलर वेट है वो अलग होगा और Na प्लस का अलग होगा और Cl माइनस का अलग होगा, तो दोनों के मॉलिक्यूलर वेट में डिफरेंस जाएगा। तो दिस इज व्हाट वी आर टॉकिंग अबाउट हियर। सो हमारा फॉर्मूला आगे चल के हो जाएगा m theoretical upon the m observed. So in this throughout the video we are gonna talk about a lot about this formula. तो हमारा जो theoretical weight है वो अलग हो जाए, theoretical molecular mass है जो कंपाउंड का हमारा वो अलग होगा और जो ऑब्जर्व्ड है वो अलग होगा, लेकिन हमको क्वेश्चंस में क्या दिया होगा, हमको क्वेश्चंस में दिया होगा theoretical. So that's it for this. Now moving further, calculation of Van't Hoff factor. So first of all we will talk about the dissociation reaction, and the reaction that we are using here is A converting into NB. So what is dissociation reaction? जब कोई एक मोल कंपाउंड हमारे n मोल बनाता है, n can be here 1 2 3 anything, the 1 mole of anything makes n mole of compound, तब हमारी dissociation reaction होती है, means the dissociation of first compound. नाउ अगर हम इसका एक मोल हमारा टूटता है और हमारे बनाता है अल्फा मोल, इसके अल्फा जो है वो टूट जाते हैं, तो इसके कितने बनेंगे, इसके बनेंगे हमारे n अल्फा। तो हमारे अब सॉल्यूशन में कितने मोल हो जाएंगे टोटल, अगर हम इन दोनों का एडिशन करते तो हमारे अब टोटल सॉल्यूशन में मोल हो जाएंगे दैट इज 1 प्लस n माइनस 1 अल्फा, एंड दिस विल बी द आर वैल्यू ऑफ I, क्योंकि हमने पहले ही बात किया था कि जो हमारे सॉल्यूशन में के अंदर जाके जो मोल्स होंगे टूटने के बाद, that will be our value of I. So this will be our value of I for a dissociation reaction. I is equal to, for this reaction will be 1 plus n minus 1 alpha. Keep this formula, remember, because we are going to use it a lot in the upcoming video, and this will be also useful for you to to solve the questions. Now, as for dissociation reaction, value of n will always be greater than 1. For the dissociation reaction, the value of n will be always be greater than 1. Why? Because here the molecule breaks and forms more than one compound, or form more than one number of moles of the other compound. So if value of n is always greater than 1, then we have initially taught that m theoretical upon m observed. This was our formula for the previously we have found. So now if I value is greater than 1, then what will happen? Then the m theoretical will be greater than m observed. This is our value. Now moving forward and calculating the other values. Now we have different cases, like in the solution we may have the strong electrolyte, weak electrolyte, or any other kind of thing. So first of all, talking about the strong electrolyte. So if we talk about electrolyte, the electrolytes are the substances which breaks into ions when we put them in the solution or solvent. So first of all, talking about the strong electrolyte. So strong electrolytes completely ionized when they dissolve in the solvent or solution. So if they are completely ionized, that means their alpha, that is degree of dissociation, will be 1, or we can say will be 100%. So this is alpha is 100%. So now moving ahead, so there are three categories in which strong electrolytes are divided, or we can say कि स्ट्रॉन्ग इलेक्ट्रोलाइट्स को 3 आगे कैटेगरीज में डिवाइड किया गया है. फर्स्ट ऑफ ऑल, स्ट्रॉन्ग एसिड जो होते हैं वो स्ट्रॉन्ग इलेक्ट्रोलाइट होते हैं, क्योंकि जैसे ही हम इनको सॉल्यूशन में या सॉल्वेंट में डिसॉल्व करते हैं वो आयंस में ब्रेक हो जाते हैं. जैसे कि हमारा HCl बनाता है H+ और Cl-, और H2SO4 बनाता है 2H+ एंड SO4 2 minus. And strong bases, yes, of course, strong bases also, when we put them in the solvent like water, they break into N+ and OH- ion. They completely break. There is no other substance we can found there. And at last we are coming to the solvent. So salts also breaks into ions and forms the anion respectively, like NaCl breaks into the Na+ and Cl-, and there are other salts also, and each and every salt forms the same ion. I mean to say that respective ions. Now coming to the next part, that is weak electrolytes. But before weak electrolytes, we are gonna learn about that how this matters in the calculation of the I. So like we have a strong electrolyte that can be anything A to B, which will further break into 2A+ and B-. Now as we know that the value of alpha, that is degree of dissociation, will be 100% here. So alpha value can be written as 1. So if we put this value in the formula of I, then I is equal to 1 plus n minus 1 alpha. This will be our value of I. So moving ahead, if we put the value of alpha from here, then 1 plus n minus 1. So I is equal to n. So for strong electrolytes, our value will be our value for strong electrolytes will be n. Like if we talk about an example, example can be HCl, as we studied this earlier. So HCl will break into H+ and Cl-, and we will get the compounds like here this is completely ionized, so I value will be 2. Number of moles that are observed in the solution are 2. Now moving ahead to the case number 2, that is weak electrolytes. So weak electrolytes are the electrolytes that does not completely ionize when they are put in the solvent. They are partially ionized, not 100%. So that means their value of alpha will be less than 1. Their value can be anything 0 to 1. Either they can be dissociate only 10% or 90%. So their value will be always be less than 100%. Now moving ahead, there are two categories by which they can be divided: weak bases. Sorry. This is an error. Weak acids and weak bases. So first of all, weak bases like CH3COH, acetic acid, and HCN. These are, when they are put in the solvent, they do not completely ionize in the ions and do not form like CH3CO- and H+. So that's why they are weak electrolytes, and same happens with the weak bases. So moving ahead, Now coming to the case number third, that are non-electrolytes. Non-electrolytes are the compound when they are put in the solvent, they do not break into the ions. And some examples of this are glucose, sucrose, urea, and mostly organic compounds when they are put in the solvent, they do not break into the ions, and that's why they are called non-electrolytes. Now moving further, it does not ionize, as we have written here, it does not ionize. So here value of alpha will be 0. So value of alpha will be 0. Then by putting this value in the formula, I will is 1 plus n minus 1 alpha. And if we put value of alpha from here, then I will be 1. So for non-electrolytes, value of I will be 1. So whenever you have given the question that the value in the glucose, then there is no need to write that this is a non-electrolyte. You self have to understand that this is a non-electrolyte, so you have to take the value of I equal to 1. Now moving ahead, so there is another case when there is not dissociation, there will be association. Like we have seen many reaction when initially 2 moles of something is given and that forms the compound A2, and this is what we call dimer. And same like this, we also get trimer and polymer. We have seen the example of polymer is very well known polythene, which are formed from the ethene. So now moving ahead, so this is a typical example of this. Now this is the typical example of this Na converting into An. So now what happens here? Here n moles of A converting into the 1 mole of An. So 1 mole of Na makes 1 by n moles of this. So if alpha is the degree of association, beta is the degree of association of this. If beta is break from here, then 1 upon n beta will form here. So as we have initially studied that I, that is Van't Hoff factor, will be the number of moles that we found in the solution. So this will be the 1 plus 1 upon n minus 1 beta. So this will be our value for the I in the case of dissociation. So if for the association, so if in the question there is a given this, then we have to use this formula for the calculation of I. Now very well known example of the association is C6H6 in the CH3COH, where C6H6, that is benzene, is the solvent and this is solute. Now questions come that why acetic acid forms dimer in the benzene. Then the very well known reason is that this is an organic compound and they are only dissolved in polar solvent, and benzene is a non-polar solvent. That's why whenever we put acetic acid in the benzene, it forms the dimer, and this is the structure of that dimer. So here what happens, 2 mole of acetic acid, that is 2 mole of acetic acid forms the CH3COOH whole twice. So here what will be the I value? I will be 1 plus, as we have written earlier formula, I will be 1 n minus 1 beta. Beta is not given here, so we directly assume that. So I will be 1 plus 2 minus 1 beta. So that is 1 minus 0.5 beta. 0.5 beta. So this will be the value of I for this compound. So by this method we can find the value of Van't Hoff factor. So I hope in this video you have learned about the Van't Hoff factor, because if you have seen each and every step carefully, I am damn sure that you will not face much more problem in the calculation of the Van't Hoff factor. So thanks for watching this video. I hope you have liked it.